guys might just feel like going home and watching it all over again sometime. All right, so to do a table in Desmos, I will say a table in Desmos is a little bit like trickier to do than some of the things in Desmos. So let's use this example. Like, let's say that we're wanting to look at. I'm going to use the AP test in Desmos, the College Board graphing calculator to make sure it does it the same that I think it should. The regular Desmos, I think. Almost everything's the same as far as how they work. So if you're looking for a table for a function, you are going to click the plus sign, tell it table. That's pretty intuitive there. And then over here is where it's a little bit tricky. If I want a formula, actually I think there might be two ways we can do this. I think we have to use the x1 though. The way I would do this is you're going to do 3, like if my equation is f of x equals 3x plus 5, you're going to put the formula over here, and you're going to use a 1 behind the x, so it's using the x1 right here, so you're going to do 3x1 plus 5. And to type an x1, you just type x with a 1 behind it. And that should enter what you want. And then you're going to enter the x values that you're looking for. So you might want like 0, 1, 2, 3, 4, and it will just calculate those for you. What we're going to be doing is we're going to be typing in, like if we're doing a limit as x approaches 2, we're going to do like 1.9, 1.99, 1.999, and so on to kind of get what's going on there. So everybody having success getting a table to come up for that? Everybody good? Any questions there? So let's look at a couple examples here. So for this one, we are supposed to do the limit as x approaches 2 from the right of 2 natural log of x minus 2. Okay? I want us to try to do this numerically. Desmos will graph this pretty well for us. But I would like for us to look at it with the table, just because that's the part of this that we're focusing on right now. What's going to happen is the questions that you get for this are usually going to look more like example 3 and example 4, where they give you a table and you have to make assumptions from that. So if I want a table for this, and then we'll look at the graph after we're done. I'm going to go over here, and instead of y1, I'm going to type in 2 natural log of x. Oh, I did the I in there. Natural log of x1 minus 2. Right there. And then I want to look at what happens as x approaches 2 from the right. Now, what I find whenever I'm doing this is that a lot of times what kids have the most trouble with is the very, very most simple thing right here. Right here at 2. First of all, I'm starting over here. I'm starting above 2, and I'm approaching from the right. So we got to think about what those numbers are. So like definitely 3 is above 2, right? Somebody give me something closer to 2. 2.5 right here. That's closer to 2. Give me something even closer. 2.1 right here. Right? What's closer? 2.01. And then 2.001 and 0001, and like you should just keep going with that, right? Especially when you get to negative numbers, I find kids just like, I find myself doing this wrong sometimes. Like, sometimes I'll do like, for no really good reason, like 2.9, 2.99, 2.99. What is that getting closer to? 3, right? Like I just get confused because I'm not focused in, especially with the negative numbers because they're a little bit different. So if you need to, like, draw yourself this out. Just be careful with it because it gets me sometimes. So in this case, like if I put in 3 and then 2.5 and then 2.1 and then 2.01 and then 2.001, 2.0001. What does it look like is happening here? What kind of larger? Yeah, it's smaller because they're negative, right? It's going down. And it looks like that's going to be the case. Now, I will warn you, sometimes you reach the, I'm just going to put a bunch of zeros. Sometimes you kind of reach the limit of Desmos, and it, it'll give you an exact number, it'll give you something that doesn't look right, or it'll say it's undefined. This one doesn't look like it's doing that here. But if you're getting way out to the end and you see a clear pattern and then you get way out to the end, something weird happens, it might be because you just went too far for Desmos. All right, so see, that's why I like to put in the 2.1, 2.01, 2.001 to see the pattern, because sometimes if you go too far, then it won't be there. Oh, I should have tried this first. I should have tried 2 first, right, to see if there's just a number at 2, but you can see that's undefined. So it looks like this is probably going to negative infinity for this. Technically, that is a limit that does not exist, but more specifically, we can say it goes to negative infinity. And if I go over here to Desmos and I type in y equals 2 natural log of x minus 2, you can see here that that natural log function, which has this shape here, has a vertical asymptote right there at 2. If you approach it from the right, it does look like you're going down to negative infinity. Okay, questions? All right, so if we try this next one, I've got limit, no, not limit, I want table here. I'm going to put in my equation right here. So I got x1 plus 3 on top, x1 squared minus 5x1 minus 20, shouldn't have gone over right there, minus 24. So make sure you put 1s with all of your x's or you'll get an arrow. It won't do what you're supposed to do there. Okay. So if we're doing limit as x approaches infinity, we just need the numbers to get bigger and bigger and bigger, right? Again, you could just go ahead and put in like a huge number. But a lot of times if you do that, you'll get something like this, and it might be confusing to you. So I would still, oh gosh, don't do that. I would still maybe start with 10, and then do 100, and then do 1,000, and then do 10,000. Because, see, it switches to scientific notation right here. So the scientific notation with a negative exponent, what does that mean when we have scientific notation with a negative exponent? Decimal gets moved to the left. So that means that's a tiny number, right? And if I keep going, I just keep putting like a lot more. You can see that negative exponent just keeps getting higher. What is this very, very, very close to? 0. So this looks like this probably right here approaches 0 for that. Using a table to estimate is never a guarantee. The function could do something odd that you're not expecting, but it supports that answer there. Okay? All right, let's move on to our next questions. This is more like what you may see on the test, is they may ask you like a question like this where they give you the table, because if they give you Desmos to work out those problems like I did on the last one, they probably also you could also use the graph. Now, sometimes the graph is not very clear, and the table can help you clear that up a little bit. So, like if you have a graph and you're like, I don't really know what that means, you could try the table to clear it up. Or you'll get a question like this. So, it says, which statement is supported by the table below? So, if I look at my table, I've got 1.5, 1.9, 1.99, 1.999, and then 2.001, 2.01, 2.1, 2.5. What X value does it look like we're kind of interested in here? What do you think, Connor? It looks like it's probably 2, right? Because like this here, we're getting like closer and closer to 2 from the left, and then over here, we're getting closer and closer to 2 from the right. So it looks like X approaches 2 is sort of where we're considering. Now, if you look at your answer choices, I got the limit as X approaches -4 from the left. Do I see anything on this table about X approaches -4? No, that would be like way down here, and they don't give me information. Now, it doesn't necessarily mean that this is false, but is it supported by the table? It is not. So C would not make sense as an answer choice here because that information is not available on our table. It doesn't necessarily mean it's false. It might be true, but we can't support it with our table, so it's not a good answer choice for this. The other 3 options, I've got limit as X approaches 2 is going to be -4. So if I look, 2 falls right here. Like 2 would be right here between 1.999 and 2.001. Does it look like that limit is -4? Is this a one-sided or a two-sided limit? Is it from both sides, or is it only left or only right? Whenever I'm looking at answer choice A. It's going to be two-sided. It's both sides for this one. Do both sides appear to go to -4? No. So this is not going to be it. But does one of the sides seem to go to -4? The left side, right, the numbers below 2, -3, -3.5, -3.83, -3.97, kind of look like we're getting closer to -4. So from the left, this is supported. Does the limit approach to, as X approaches 2 from the right, equal -4? It is not. It looks like it's probably +4 for that. Right. Now, this is not a guarantee. It might be 3.98 is what we're approaching. So, again, the question is supported, but not necessarily true, right? Okay, that leads into my next question. Which statement must be false according to the table below? All right, so I've got limit as X approaches 0 of f of X equals -5.5. So this table, what X value does it seem to be like focused on? We got -0.5, it looks like 0 is kind of like where you're trying to see what's happening, and 0 is like right here. Does it look like on this table that the limit would be -5.5? Quite possibly, right? Like these two are the same, but you're decreasing for each one of these. So definitely we could be like meeting at that point. So this seems to be true. So it's asking which one must be false. So I would not say that one. It seems to be true. B says that the limit from the right of, as X approaches 0 of f of X, equals the limit as X approaches 0 from the left of f of X. Does it seem like they're coming to the same number here? Like that looks like it's probably true. I would say that definitely does not have to be false. It looks like it probably is false. All right. C says the limit as X approaches -5.5 of f of X is 0. what sort of happened here? Like, if I gave somebody this table and I said, write me a limit from this table, and somebody wrote down C, what do you think they kind of did right there? Like, switched up their X's and Y's, right? Like, this, because the limit as X approaches 0 does look like it's negative 5.5. Does this table show us anything about the limit as X approaches negative 5.5? It is not. Does it look like from our table that this is true? Not really. Does it have to be false? Do we know? Do we have any clue what happens at negative 5.5? Could it be true? Maybe. We don't know, right? Like, we're not sure about this. We'll hold on to that. Let's look at the other one, because like if we mark out that one, then that should mean that D is the answer. So limit as X approaches 0 of f of X does not exist. What did we say we thought the limit looks like it is? It looks like A is kind of like what you're making the assumption here. So it feels like D should be false, right? Like that should be false. But do we know exactly what happens here? We do not. Could they, like at 0.0001, could it go down to like negative 7 and then negative 9 and negative 1,000? And could you have like negative infinity, which would be limit does not exist? Maybe, right? Do we know for sure things from tables? We do not. We don't know what happens exactly here at 0. So this is a trick question that I put on here on purpose. It's still a possibility this does not exist. It is a possibility that negative 5.5 equals 0. Okay, so I've put this on here on purpose as a trick question. No answer because tables do not give enough info to say limits are false. Okay, the only thing you could say is false from here, it is like if I said f of negative 0.5, if I said that equals 7. That is false because f of negative 0.5 is negative 4. That is on our table, right? Like I can make an assumption of what that value is at that point. Like this could be false, but limits you can't know for sure from a table. It's more like example 3 where something is supported. Right now you're not really going to see questions, definitely like not like number 4 that don't have a correct answer. But what's going to happen is later on when we start learning more about limits and derivatives and other things, they'll make you a list and they'll say like which one of these must be false, and one of the options will be a limit, and then they'll give you other things about derivatives and integrals and like other stuff we learn later. It's almost never going to be the limit if it's from a table because you cannot make like conclusive statements from a table for limits. All right, so I'm going to have everybody pick a partner that is not the person that you're sitting beside right now. So you'll pick somebody besides the person that you're sitting beside right now. You are going to have to create a written description, a table, and a graph for this. Because one of the main focuses, we did this a lot in pre-cal, but we'll do it a lot here, is multiple representations of everything. The only thing we're not doing here is coming up with like an equation of the function. That would really step it up to a pretty difficult level probably to come up with. I'm not even sure if like it'd be necessarily possible to anything would be possible with a piecewise function, but you might have to go piecewise on some of these to get them to work. So I'm not going to make you write the algebraic equation, but we're going to give the written description, the table, and the graph for each one of these, and try to have all those three things match up. So I think the written description is probably the easiest thing to do. This is mostly that first, 1.2, where you're just given the limit in words. So for this, I'd probably start with domain here. I would say the domain of g of b is -2 to infinity, and the limit as x, I'm about to mess it up, the limit as b approaches -2 from the right is infinity. Okay, so that should probably be about your easiest part to do. You're just writing out whatever information they've given you in words. So, a few things I want you to pay close attention to, because what we're going to do is you are only going to do one problem. You and your partner are going to do one problem, and then we are going to post those so we can see the answers to all the problems, and the job of everyone is going to be to look for mistakes in the other group's answers, right? So here's one to watch out for. What is on our horizontal axis for this graph? What variable is our horizontal axis here? It is b, right? It is not x. I want it labeled on the graph. If you leave that off, then that is a mistake, right? And what should I label my vertical axis? G of b. That also means on this table right here that this line right here is b, and this line right here is g of b. I want it labeled on the table as well, right? For that. So you want to make sure you get those things right. Some of them are just like an f of x, where you probably would do it correctly without even thinking of it. Here they've used different variables, so you want to make sure you're consistent with that. On the AP exam, if you accidentally turn something into f of x, it is okay, as long as there's no other functions in the problem. But a lot of the problems will have, they'll have a f of x and a g of x, and you're comparing them. So if you accidentally call one of them f of x because you've just sort of reverted back to the standard on that, you're not going to get points for it, because they're going to assume you're talking about the other function. So you got to be really careful on those. So we've labeled all this. My domain is only -2 to infinity. So at -2, right here, I really only want to have the function to the right of that. I can't have any values to the left of -2 because they're not in the domain for this function. Okay? And my function tells me that the limit as b approaches -2 from the right, so over here approaching -2, I go to infinity. What is that going to look like? What am I going to have? Okay, Michaela's going like that. I'm going to have a vertical asymptote, and it's going to be going up in this case, right? So, so does it matter what happens over here? Does it matter what the graph does? Not at all, really, except for it needs to still be a function. I want all of these to be functions, so don't do something crazy where it won't pass the vertical line test. But over here, at negative 2, I'm going to put myself a dotted line just because it's easier to draw. That's not part of the graph, but that just indicates that vertical asymptote. I know over here I've got to get closer and closer and closer to that value. Over here on the right side, it really doesn't matter what it does. I'm going to have it like do like this, but it could do anything over there as long as it still passes the vertical line test. I want your table to focus in on the interesting features of the graph. So domain being negative 2 to infinity basically just means we don't want to include any number smaller than negative 2. You can include that on your table if you want, but you don't necessarily have to. The limit's the big thing I'm concerned with, like I want to see. I want the tables to have like the least value up to the highest value, so don't put everything backwards. Here's a good example of where you want to do it backwards, because at negative 2, if we're approaching negative 2 from the right, you want to go, well, that would be like negative 1.9, negative 1.99, negative 1.999, negative 1.9999. But on the table, it needs to go from least to greatest. So, it'd be a good idea on this one to do negative 2 and undefined. Because negative 2 is not included in our domain. Our limit approaches infinity. So negative 2 is undefined. And then I would say, like at negative 1.9999, what does our value need to be? Like, we don't know it exactly, but what should it be? Or what kind of number should it be? What? Not necessarily. Good. Very high number. You could even use scientific notation if you want to get like really big numbers. But it's got to be a pretty big number. Must also be positive, right? So we're like, it really doesn't matter right here. Do 100,000, do a million, do a gazillion, do whatever, you want there. But if I back this off, it's only 3 nines. What do I have to have here? It's got to be less, right? It doesn't really matter. Like, we can't see that level of detail on this graph, so it doesn't matter how much less. I'd probably do 10,000 if I did 100,000 there. If I do negative 1.99, again, got to be less. Doesn't matter really how much less. I'm going to go 1,000. Negative 1.9. Maybe that's 100. At this point, we still got 4 more boxes to fill in. So you might want to start like looking at what it actually looks like it on your graph. Maybe you want to do negative 1.5. Well, negative 1.5 is like right here. So maybe that is 1, 2, 3, 4, 5, 6. Right. Once you start getting to the level of detail you can actually see it on your graph, start using the points on your graph. I want these to match, right? So if I did negative 1, what should I use? At negative 1, looks like my graph's about 4. If I did 0, I would use 2. And then maybe, I'm just picking points now. 3, 1. I just picked that one because it is pretty close to grid lines on what I've drawn, right? Now, this is not nearly as important because you're just filling in so that you got some information about the graph. What I really want to see is your table needs to have information about what's happening at that interesting point for your graph. All of them. Yeah, do all of them where your x values are least to greatest. So, like, you might feel like doing it the other way on some of these. Like, I would kind of want to do it the other way on this one. Like, start at negative 1.9, negative 1.99, negative 1.999, and do it that way. But you almost never see them give you a table like that. So I want us putting at least to greatest because that's like, if it were multiple choice, that's what you're going to see is answer choices for that. So you guys get the idea of what we're doing here. Very similar to the warm-up, but we're throwing in a table now too in a written description. So if everybody will